Alright, so today we're going to be covering the classification and defining the real numbers. So when we think about the real numbers, basically we're just talking about the number line, right? And what kind of stuff do we have on the number line? Well, we have 0. You can think of that as the middle of the number line. Then we have positive numbers, right? We have negative numbers. We have fractions, 1/2 for instance. But then we also have different other kinds of numbers, things like pi, right? So this would be just slightly above 3, for instance. And so we're quickly going to go through and define what kind of numbers exist on the number line. So the first set we have is called the natural numbers. And I mean, these are all numbers, so I'm just going to call them the naturals. And the symbol for it is this fancy N. And so, well, what are the naturals? We can kind of think of these as the counting numbers. So if there were chairs in a room and you wanted to count them, you would start with 1, 2, 3, and so on and so forth. Okay, we have the whole numbers. And the symbol for this is a W with a line through it. And the numbers here, basically the same as the naturals, but we include 0 here. Okay. Then we have the integers, which is like a double Z type of thing. And the integers are basically all the positive and negative whole numbers. So we'll have dot dot dot, right, because there's infinitely many negative numbers, but we have like -1, 0, +1, 2, right? Dot dot dot. Okay, then we have rationals. And so when you see the word rationals, you should see ratio, and you should think fractions. So these are all the numbers that can be written as fractions, and it's written as a Q with a line through it. And so the kinds of numbers that are in here, right, we can't write them all, but for instance, 1/2 is in here, 0 is in here because we can write that as 0/1. 1 is in here because we can write that as 1/1, right? 2/3 is in here. Basically any fraction is in here. And so if you look above at the numbers we've written, we have like fractions, 0, -1, and 1. And you can see at least most of these are in one of these groups already. But pi, we still haven't put pi in any of the categories yet. So where does pi go? Well, it's what we call an irrational number. So the irrationals. And this doesn't necessarily have a symbol for it, but it's basically all the numbers that can't be written as fractions. And so the symbol for all the real numbers, everything that fits on the number line, is this guy. It's that fancy R. So if the irrationals are everything that isn't a fraction, right, we can write it as R and then take away all the fractions, all the numbers that we can write as fractions. And so the strict definition of this is P over Q, where P is in the integers, right? It's a positive or negative whole number. Oh, excuse me. Let's back that up. Okay. That is actually the definition for the rational. So we gave examples here. I'm going to quickly write the strict definition. So P over Q, where P is in the integers, right? Positive or negative whole numbers. Q is in the integers. But since a fraction, right, like 2/3, we can't have a certain number on the bottom, right? We can't have 0 on the bottom because then we would be dividing by 0. So the bottom number here can be any positive or negative whole number, but it just can't be 0. And so that's the strict definition for what the rationals are. And so the irrationals are all the numbers on the number line that can't be written as fractions. And so the strict definition would be non-repeating, non-terminating decimals. Okay. And remember that fractions can be written as decimals, and decimals can be written as fractions. Except there are certain decimals that can't be written as fractions, and that's what the irrationals are made up of. And so the number pi, right? It's 3.1417, keeps going. It's non-terminating, which means the number never stops, right? Because it goes on forever. But it's also non-repeating. You're never going to get like a copy and paste of like the first set of, let's say, the three numbers, and then 141 again, 141 again, 141 again. It doesn't happen because we constantly get different numbers. So that's why it's non-repeating. The numbers never repeat, and it's non-terminating. The numbers never stop. So this is an irrational number. Okay. So if you have a decimal like this, right, where the threes repeat, which we can repeat forever, so we would write that as 0.3 with a hat on top of it, right? This is non-terminating, right, because the threes go on forever, but it's not non-repeating because it's only just threes repeating after themselves. And so this is not an irrational number. This is actually can be written as a fraction, and it's written as 1/3. And if you were to plug this into your calculator or do long division by hand, you'd see that you keep getting threes. So 0.33 forever can be written as a fraction, and so it's not an irrational, which means not a fraction. And so this number, goes in here. When I write it in this form, it's a lot easier to tell, but we're going to use this definition basically to figure out whether it's going in the irrationals or not. Yeah, so let's throw out a number really quickly, examples of a couple numbers, and we'll discuss whether they're rationals or not. So we gave one example of the irrational numbers, right? But let's put a couple more. So irrationals examples, right? So well, we know we have pi in there, so that's cool. So what other kind of numbers are non-repeating, non-terminating? Well, one that you should also recognize is e. It's like 2.7 something something something. This one also never repeats. But also square roots of numbers that don't have perfect squares. It's like square root of 2, for instance, square root of 7, right? And so these are examples of irrationals, numbers that you can't write as fractions because the decimals continue on forever. And so if I was to give you an example of this, right? Is this an irrational or is it rational, right? Because the rationals and the irrationals are mutually exclusive groups, which means if you're in one, you're not in the other. You can only be in one of these groups at a time. And so when I write the number this way, you may think, okay, it kind of has the same form as, the square roots over here. But because the square root of 100, this is a perfect square, we can write this as the square root of 10 times 10, which is equal to the square root of 10 squared. And since square roots and squares undo each other, right, this is just equal to 10. And 10, that can definitely be written as a fraction as 10 over 1. So we would say the square root of 100 is a rational. And really it's because we can simplify this, right? So 10 is a rational. Because all whole numbers can be written as fractions. You just put them over 1. So with all these like sets of numbers here, you'll notice that in this group, right, the naturals, they're inside of this one, right, because it has all the numbers that the naturals have, and then the integers have all the numbers that are inside the whole numbers, because 0, 1, 2, 3, right? You can see them all in here. And so the rationals have all the numbers that the integers have, right? Because they have all the whole numbers, positive or negative. We can put 1/2, it can be negative 1/2, it could be 2/3, it could be negative 2/3. So the rationals contain all the integers as well. And so this is basically like, you can sort of think of it as half of the number line, the fractions, numbers you can write in fractions, and the other part of the number line are these guys, the things that we can't write as fractions. So all the real numbers on the number line are the set of rationals, right? So they're either in here or they're in the irrationals, which, I mean, we basically define as take all the real numbers and take away the rationals. So they're either in one of these two groups. I'll stop the lecture there, and on the next one we'll talk about how to convert decimals and fractions.